You have to describe your data, and that's the level. After describing your data, you now know the status of the data. So the health status is like somebody going to the hospital. When you get to the hospital, the first thing they do is that you have to first of all lay your complaints. It's true now, so that we can easily know which sample we need to collect. So after doing that, collect samples, get the results, and see if to diagnose what actually is the problem. So after the diagnosis, it is either you are okay, it is either you are not okay, but it depends on the level. If you are not okay, it's not every patient that is the same. There are some patients that their disease is still at the elementary level. There are others that they have the pathogen, but it has not formed a disease. The pathogen is still in their system, you see, but the disease has not been formed. There are others that they are at the chronic stage, and there are others that they are at the acute stage. And so when you go to the hospital, you first of all have to take your sample and see what is happening. So when you go to the field and you come back, you have to start by describing your data. You diagnose the data. Okay, this is the state of the data. Now, after diagnosis and you report, we now have to check if you're okay. If you're okay, or if the data is okay. Now, if the data is sick, we have to administer medications to your data. It's the same thing with hospitals. It sounds funny. It's the same thing. So if your data is sick, there are two ways. We transform it. We transform the data. That's giving medication. So not everybody having malaria is at the same level. There are some people that they may be having some light is not that severe, or not every disease is at the same level. For example, you're having headache. Another person is having malaria. Another person is having cerebral malaria. Can you give paracetamol to somebody having cerebral malaria? Will it work? You see that you are giving the wrong treatment. Okay? So when your data is not well, we administer medications. And what are the medications we administer? We have log transformation, inverse transformation, square root transformation, among others. So normally we're supposed to study very well before we come for this, just to look at how to test your data. Right? So when you have given these various treatments your data, if in case it is still sick, that is a problem. So if your data is still not well and the situation is very bad, what do you do with such a patient in your village? If you go to the hospital and the doctor they have given you every medication, herbal medications. Why did you start with herbal medication? People don't have food trust, and that's the problem with Africa. You pray for the prayers. So if you bring your data and we have given paracetamol, it does not work. Which herbal medication do they give in your village when you're having cerebral malaria? Beating. That one does not exist. They don't beat you. In the village, if you are having malaria, there's one pot that they prepare some medication there. Then they make sure that you are well, they put it in a closed system. A closed system. It's not really closed, but it's a closed system. So that the temperature within is constant. So if the temperature is at 37 degrees, you have to sit in that 37 degrees to when they make sure that the aroma or the odor that comes out from the ball gets into you at the optimum level. And that's how the person will sweat until, and at the day end, they release you. But we have to be very careful that we don't involve tradition to herbalists. The one that they invoke, that's the problem. Because sometimes you do this data like this, you give that medication data, it does not go. So we send the data to another room. In data analysis or in data science, we call that room distribution free room. It's not a mosque, it's not a mortuary. We call it distribution free, commonly known as non-parametric. There, they'll give you medication that it must work. There's no way that it will not work. So the problem is, with non-parametric, there are some disadvantages. Number one, there are some scientists that will not really accept you to do non-parametric analysis. They may not accept. They may not want it. Why? Because it's less informative. Non-parametrics is less informative. And that's one of the main things. Less informative for non-parametric. That's why there's some people that they want you to transform it till it is normal and run parametric. Is it clear? So please, we are trying to make sure that you don't cram things. So remember, we are doing a quantitative analysis. We said when you take your data from the field, you first of all diagnose it. You know the status of the data. If it is okay, you do parametric at once. If it is sick, you have to start thinking of which medication to give. Now, if your data is having headache, that is live fever, right? Your data is having headache. We give the data square root transformation as medication. So square root transformation is a paracetamol to your data. Do you understand? Now, if your data is having malaria, we give your data log transformation. And if the data is having cerebral, the one that sometimes you think you are very powerful, you give your data inverse transformation. Inverse transformation. So after doing all this, we can now run our parametric analysis. Okay. Is that okay? But the question is, what are the things you use to test? What are the things you use to test to check actually if this data is not good, it's not well, apart from descriptive? What are some of the things you use to test? At the elementary level of education and secondary, data science has to do with accumulation of knowledge, right from the basic to the tertiary education. Those of us who are running from number line, you meet it at the PhD level. Those of us who are running from plot X against Y, you're running from me now. You meet it here, you're not running from me. There is no way. X against Y, you have to plot it. Now they'll tell you that go to the board. Some of us that were always sitting behind. You know, in class, those are very intelligent sitting in front. Some of us were sitting behind, and they'll tell us why, or they always say that your mates are not in this class. Your mates at this time they have money, they're married. Allow these children in front to study. Is it true, sir? Huh? That's what we're saying now. It's allow the children in front to study. So we have to do research to see if those who are in front are always very intelligent. And those of us who are sitting behind, we are the people who see off. We see off those who came to school. So I was saying that normally this is accumulation of knowledge. Okay. Testing confidence level can be a modified word, but the concept of confidence level, you have to know also the concept of the number line. You have to know the concept of the number line. So those of us that we were saying that decimal places, 2 decimal places to the right. So this one is not making sense. You do decimal places here. So you should be able to take 2 decimal places to the right, or one, maybe whatever. So there are various ways that we use to check our data if it is okay before giving medication. Number one, we're talking yesterday of scatter plot. You know scatter plots, right? Yes. Scatter plot, you are plotting x against y. I draw the line of best fit. That's one way. And the data that is very much the data that is quite far from that line. That is quite far from the line. It's called an outlier. All right, which is those are the data that affects the normality of the work. So you have skewness, you have ketosis, you have the KSS, you have Sapir weighted. I'm going to give people the notes. Right? I'm going to give you the notes. So you have what we call skewness. Skewness is synonymous to the word distortion. Synonymous to the word distortion. So we don't want our data to be distorted. You can imagine you take the salary of Cameroonians, you take the salary of a minister in Cameroon, I take the salary of one market mami, and somebody working in documentation as a secretary. What do you think will be the outcome of that work? Will it be rational? Like take the salary of a minister, I don't even know the salary of a minister in Cameroon. But I know it cannot be less than 700,000 as in salary. That's what I think. I'm not saying that is what is there. It's not a fact, it's my hypothesis. I don't have evidence. So you take the salary of a minister, you go to documentation, you take somebody working as secretary, about 100 of them in Cameroon. You look for one minister, look for one two. You analyze it and send to the United Nations. This is the salary of Cameroonians. Those two will affect me. Those two. You see that average earner in Cameroon will be about 200,000. You have distorted that work. You see, so those are what we call outliers because they stand out, and when you include it affects the true what is really happening in that area. Do you understand? So when you want to do a study, you have to be very careful of outliers. Don't go and collect outliers in the field and bring and be troubling yourself with data. No. First of all, first of all, know how to correct the right data from the field. If you are looking at, if they really want to know the salary of workers in Cameroon, there's no way I will collect any administrator. I have to do my purposive or no probability sampling. I get those people that they really know what is happening in Cameroon, and I report that. So based on skewness, there's positively skewed, negatively skewed data, right? Positively skewed and negatively skewed. Data can be positively distorted, can be negatively distorted. You see? And ketosis also has to do peakness of your data. Peakness. That's why yesterday we were talking about the data can be mesocritic, means it's okay. Leptocritic means it is above +2, +3. Platycritic means it is below -2, -3. But one of the things we also have to look at when it comes to testing for normality is the aspect of the hypothesis inferential. So there are two techniques we're looking at today when it comes to checking for normality. We hear of the Shapiro-Wilk test, and we also hear of what? The Kolmogorov test. Shapiro-Wilk test tells you of your sample size. You don't use it with sample size greater than 50. Kolmogorov test, you don't use it with sample size less than 50. You use it with sample size greater than 50. While the Shapiro-Wilk test, you use it for sample size less than 50. So at this stage, let's just do some normality check. Let's use skewness and ketosis with the data we did yesterday. We'll just proceed. Or we'll just continue with the data of yesterday. Everybody's having it then. Yeah, please. You are not having just what we had there. So you have here skewness, you have ketosis, right? So the interval for skewness is between +1 and -1. So if your data lies in that interval, the data is okay, it's normal. When it's above +1, we are saying their data is positively skewed. When it's less than -1, we are saying that your data is what? Negatively skewed. So I would like somebody to interpret this data. We have three data set here, variables here. You have sleep time, study time, and height. You have sleep time, you have the study time, and the height. You have the skewness, and you have the ketosis. Let's first of all start with skewness. Can somebody interpret us skewness, if it is positively skewed, negatively skewed, or if it is normal? Can you see clearly from there? Hmm? No, look at mine here. Yeah. Are you seeing from there? Right. You have skewness 0.438 for sleep time, 0.905 for study time, and 0.230 for height. So the question is the data distorted or not? It's not distorted. What is your opinion? What's the again? It's not distorted. Are you sure? You don't know. I don't know. It's not an answer. If you say yes, you know we could justify. It's more preferable to say yes or no. We said the interval of skewness is positive one and negative one. Or what we are saying is that it should not be greater than 2. Okay. So look at the interval there. We have 0.438, 0.905, 0.230. What can you say about that? It's positively skewed. Look at the number of decimal places. You have to start looking at decimals now. That's 0.230. This is not 2 point. This is there's a 0 here. Negative 2. Then there's a problem you're hiding. There's a problem you're hiding. So you see that all the data, sleep time, study time, and height, they're okay. Yes, what is your worry? I'm going to show you, I want you to understand first here. You're not seeing. Whatever means possible to come here. So what is it because The spin is yellow. They're having issues with our projectors. Interpret there now. Are you seeing there now? Let me test your side. Close this other side. Normally, is it normal? What do you say normally? Okay, so all of the data is not positive or negatively skewed. It's okay. Now let's look at ketosis. Ketosis, we said, if you go online, you are going to have, you can have, that's different scholars with respect to ketosis. Some people will tell you that ketosis is within -2 and +2, but perfect distribution of data is supposed to be 0. Both for skewness and ketosis, 0. Perfect distribution. Now, there are some persons who say ketosis lies within the interval of -2 and +2, others -3 and +3. That is why sometimes we don't just conclude with respect to measures of distribution. We have to go down to the section of inferential to test using the inferential method. So if your data is above +2, we say your data is leptocutic, okay, in nature. Lepto, as in lepto. Leptocutic, the cutic is Kurtic. I'm going to send a note. So your data is set to be leptocutic, and when it is below -2, yeah, we say that your data is platycutic in nature. So normally these are normal terms that we use. You must not bring down everything to the simpler unit. Is it clear at this stage? So for you to run your look at distribution, you go to analyze, descriptive, frequencies. So you have analyze, descriptive, you can go to frequency, you come to descriptive, because you still have your skewness and ketosis here. Continue. So let me take the procedure all over. You have analyze, descriptive. You can either come to frequency or descriptive. They come to options, have skewness and ketosis. You take continue and you take OK. We present this kind of result you have made in life. Okay, so you look at weight, skewness, You look at that for ketosis, right? So you see that 1.001 is almost like 1. Almost like 1. It's not really that far. 1.5, it's okay, it's within the limit. So I'd like us to check, to look at the distribution for, I'd like us to look at the distribution for maths, reading, and writing. Maths, reading, and writing. Any of the above. I just want to see results. Some other institutes that not come to them. Natural or artificial selection. You did reading comprehension. In ordinary level. I'm sure you had very good performance. Directed writing. Then the other one. All the data are okay. Alright. Next exercise. Check for sprint. Check that for sprint. It's okay. Check your method now. Are we okay at this stage? Can we proceed? You know, in research, we live in majority. If I conduct my research is 60%, then it shows that it is going. If it's 40%, it shows that it's not going. So, in the context of research, I have to move forward. So that you're having a problem with your confidence level. You have to adjust your confidence. This is a negative 2. So you know that we are still in the laboratory doing some tests, and the patient is there waiting. So the next test we are going to conduct on the same sample is what we call the PP plot. Before we go to the inferential, so on analyze, you go to descriptive and you go to explore. Now let's check for normality for height here and weight, since they are continuous data, and English. Statistics, let's just take outliers, plot, normality plot with the test, inclusive. So it's like the first section has to do with data exploration that we did yesterday. You have test of normality. You have the height, quantile plots, box plots, normally, when you plot X against Y, you're supposed to draw the line of best fit. You see the line of best fit. Can we say the data doesn't have any problem? Has very few outliers and they're not really far from the normal line. Okay? If you come down here, you see that this is a kind of, can we say, longitudinal presentation. But sometimes graphically we don't end there. That's why we have to look at differential. Okay. So we have to go now to the inferential. The inferential, this is it. There are some key things you are supposed to note when you are working with inferential. And we said inferential, you have to start talking about the concept of p-values coming in. The concept of p-values coming in. And there are two tests here. You have the Kolmogorov test, you have Shapiro test. The first is the KS, I also call it the KS test. The second is the SW test. What is the main concept behind the SW test and the KS? The main concept behind the SW test is that you are dealing with smaller samples of less than 50. The main concept of the KS is that you are dealing with samples of what? Greater than 50 or what? Larger samples. You should never forget that principle. Now, remember that in inferential, you must state your hypothesis. You must state hypothesis. And the hypothesis for normality is that H naught means that data is what? Normally distributed for the null hypothesis. Alternative hypothesis, data is not normally distributed. That is a hypothesis for normality. Your H naught states that data is normal. Alternative hypothesis states that what? Data is not normal. Which therefore means if my result is, my p-value is not significant, I say that the data is normal. If my p-value is significant, plus my data is not normal. Do you get that? Because significant p-values tells you that it's like telling you that your data, the minimum value, the distance from the minimum value to the maximum value is significant. Do you understand? It's telling you the distance from the minimum value to the maximum value is too big. So that's why it's giving you significant results, which therefore means your data is not okay. Now, if I compute and my data is not significant, it's telling me that the distance from the minimum to the maximum is not okay. So in that case, it's okay. But if it is wide, it gives you significant results. It's telling you, no, there's a problem. Check your data. Having an issue. So in this case, the first thing is that we look at the sample size. Sample size. The sample size is 336, which of course the concept of the SW test does not hold here. It's true now. So we start looking at what? Start looking at the KS test. Now height is 0.077 at 5%. Is this significant or not? Look at the significant value here. That's 0.077. We are working at 95% CI. 0.05 significant. So the question is this data, is it result significant or not? It is not. Why? It's greater, of course, right? So in this case, is your data normal or not? It's normal, yes. So in this case, it's normal. You understand? So you have looked at these are remember that we are still in our own lab, okay? We have used various tools to take this sample, the sample of this patient. We have even gone to the extent of what? The inferential section, and it is shown that height is okay. So we can confidently give out the result at this stage. So weight is giving another information. Is it okay? Is weight normal? This is weight here. Is it normal or not? First of all, is it significant? So what does it now imply? It's not normal. You see that weight is having an issue. Weight is having an issue here. The last is English. Is English okay? That's 0.200. We said moving decimal place 2 times to the right. From primary school, we are using here. So we are having issue of knowing if it's significant or not. Move the decimal place 2 times to the right. The first, this is 0.077. If I move it two places to the right, this 1, 2, that's 7.7. It's above 5%. But you will not report it in terms of percentage, no. If I come here, I move my decimal place 2 times to the right, this is 1, 2, 20%. It's above 5. If I move my decimal place 2 times to the right, this is 1, 2. It's still 0.0. So okay, it's significant. It's not normal. Is it clear now? You're not getting it? Yes, I'm not getting it. Oh my God. Not me. Okay. Have you understood? But you explain. Are you sure? It's good you understand before we proceed. That's why we had to hold. I cannot hold and move on that you're not okay. You read through.
Because I made the complete point, you said it will be the majority. So if I am lost and I need clarification because 2 or 3 people have understood, I should not understand.
Even 50% can move forward.
So if I'm confused by that and I make a mistake and I bring it to your notice,
of course, that's what I'm here.
That's why you're here. Then you don't tell me that 60% of the class have understood before to that.
That's a normality. We'll show you later. Anyhow, I was just kidding by the percentage stuff. That's why I'm here. And even the speed that I'm teaching, it's quite slow so that you can understand. If you don't understand, then there's no significance of me being here. If it's one person, you go out for the Lordship. It's not the one that we have. Okay, so we're saying today that, listen, please. We're saying today that what we have interested. Okay, whenever I hear of the word inferential, know that you have to start thinking of P values. You have to start thinking of P values. And statisticians, we have very common types of confidence level that we use. We said 90%, 95, and 99%. 90%, the alpha level is 10%. 95, the alpha level is 5%. 99, the alpha level is 1%. You can also present it as 95%, 0.05, 99%, 0.01. They have 90%, 0.1. Okay. So significance is when the value you have computed is less than the alpha value that you have stated for your work. Every research work has the alpha value you're using. So most commonly we have 95%. It's very common. But there are some cases where your confidence level should be 99%, especially when you are dealing with things that you cannot be replicated, like human lives. You cannot be working on a human being at the level of 95% confidence interval. It's understood now. So we have 3 alpha levels. Here we are using 95% or 0.05. So you have to compare now that 0.05 to this one here. So if the 0.05 or 5% is greater than these values, then it's significant. But if it's less than these values, then it's not significant. So here you see that this is about 7.7%. It's not significant. This is significant, and this is not, because this is equivalent to 20%. You see, that's how we compare. Then we also look at other ways of testing for significance. We have what we call the confidence interval. We are going to go into detail. When we are treating regression, we look at how to report findings. Some people may report findings using just confidence interval. You look a p-value, you will not see it. You can report findings using the Fisher value or the t value, apart from the probability value. You okay at this stage? So sometimes I cannot proceed when you have not understood. Hey, madam, is it understood now? So you see that weight is having an issue. Let's go back to confirm. Let's just run result for weight, height, and see the distribution. If you look at weight here, you might not really see that difference. You might not really see that it's having an issue. Have you seen here? For weight, because ketosis is okay. No, it's not skewed as in you can assume to be okay. That's 1 point, it's not that far. But even look at here, you see that it's okay. But when you do the inferential, it's having an issue. You see, it's having an issue. So that's why it's not good to just confirm and say sometimes the data is fine. This stage, just go. It's always good also to look at the differential, especially for continuous data set and discrete. Especially for continuous and discrete. Sometimes you don't see it necessary. Why are you doing normality for categorical data? Okay, let me show an example. For example, you have gender. You want to check normality for gender. It's just 0 and 1 now. But you want to check for normality for smoking. Okay. Somebody online is smoking. Smoking 1.37. Let's look at inferential technique for smoking. See? We always give you very significant, that is not normal. It's not okay. It's not okay. So normality check, we mostly use it when you are dealing with continuous or discrete data. It's not categorical. Categorical as in, this is height and weight. These are continuous and discrete data set. They have gender, athlete, rank. This is nominal data. Rank is ordinal data. These are all scale. So can we now carry out the analysis? Can we move on with the analysis, please? So do check normality using either KS or SW test for spring, maths, and writing. Spring, maths, and writing. Mhm. Okay. Let others finish. All right, can we proceed? So we are going to go for break. We'll come back from break. We're talking about after doing the state of my data, what is the next step? Which medication do I administer? So go out for break.
That's what he said. Yeah.
Hello? Oh, yeah, Paul. Okay.
You have the SPSS. You have to install SPSS. That's the reason why. Can we proceed? Can we continue? So, you go to primary school. You went to buy food. You are paying. Who's somebody talking? So we'll be looking at how to normalize your data. How to normalize your data. So for you to normalize your data, we said you have square root transformation, you have log transformation, and you have inverse transformation. And we said use it based on the level of severity of distortion, the level of severity of distortion, the data.
Come again. Which method do you have?
So I'm just going to take an example. The data that was not normal, I think we have weight. Let me just do practically all of the three types of transformation so that we so you come to transform, compute variable. You have transform, compute variable. Now we are going to have a dialog box. This dialog box gives you various functions that you use to calculate, to compute. So you have the target variable here, numeric expression, a function group, functions and special variables. So if I double click on all, you see that you have functions and special variables, you have a display of them. So if I want to transform, let's take example, log to base 10. Log to base 10. I have to search for log to base 10. Normally it's alphabetically. I double click on it. It's going to appear on numeric expression. To appear with here numeric expression. So the question mark is in bracket. What do you want to transform? You have to delete the question mark. I have to look for what I want to transform. I say weight, I want to transform weight, and I send it to bracket. Now you have here target variable. Target variable is a new name because normally when you transform like that, it does not go to output. It goes back to your data set. Is it clear? It goes back to data view. So it's part of your data, it's not result. So I can say log data. Remember, it has to be one word. If I take, for example, if I type log, I put space data. I click on OK. Variable name contains an illegal character. But if I remove the space and I take OK, that's it. So I go back to my data view. This is it. Log data. Have you seen on data view? So generally, let me just give you one of the importance of this platform. This one should help you to carry out mathematical computations. And when you take OK, it's going to go to your data view. It's not resolved. Goes to your data view. I can see one, I may still want to look for the mean. I may still want to look for the mean of weight. I'll have to look for the function here. There are so many of them. You have mean, but click, you have that. Remember that mean has to do with data set. So if I want to do the inverse of weight, like inverse transformation, what is the expression of inverse? One negative one. Negative one. No. Inverse. What's the expression of inverse? IA is 1 on X, 1 on X, 1 on Y, 1 on T. 1 on X is equal to X to the power minus 1. No, what's minus 1? The same thing. Maybe that's big book. So if I want to look for the inverse, I simply just take 1 on slash is equal to it's 1 on 1 slash X. Yeah, good. 1 on I take inverse trans. Okay. Inverse trans. The last one is square root. Square root trans. SQRT. Square root transformation of weight times square root. That data analysis is very easy, especially when you are not using chalk. So you go to transform repeat variable. Set. I want to look for log. I first of all look for my function.
Association.
725.
Log to the base 10, I double click.
I feel correct.
I can put my weight.
So example 750, 770, go for 740. It is you don't like one.
It's okay. We're good to go. Are we good to go? All right. After transforming, you still have to test. So run the differential, use the various parameters to check if it's normal now. Use KS, whatever, check if it's okay. Let's first of all analyze and check for measures of distribution and see. Measures of distribution. See that mine is okay for all of them. Let me see for you want to transform ordinal to do what? That transform is not a categorical data. You see that the best there for this work is square root transformation. It's okay. It's okay. 10.161, how come? Command did not give that. Because this is mine. Everything is okay. Okay. So I'd like us to now transform data for, go to your weight, go to your height. Put 1,000 on that height. Now let's say 300. The first data, put 300 for height. Test it and transform it using the upgrade method. So the first, instead of that 66, they put that 200. Please, sorry, 300. Pardon? 300. Run the test it. Test it is okay. It's not okay. Use the appropriate method to transform. Are we done? Are we almost on? How you doing? Cozy League. How you doing? Sparrows way, it's not that. Which one, John? So I said the first should be 200. But is it weight or height? 200. So let me fill a check. My God. It's horrible. And that's somebody's height. It is not possible. Okay. Let me try inverse. Is it high though? Okay. My gracious, gracious. Which a number of decimal places. The first minimal. Ketosis is having a problem, skewness is can manage it. It's okay. The ketosis is 14.386. Just because of that 1 hour earlier. So you see, some cases like this, if you have to end up using maybe no parametric. But at least it's good to transform because you have at least brought down at least that error. Yes. Because there are people that even when when they log transformative test, many people, I'm not even sure the test, it has been transformed already. So in cases like this, the most suitable method to use is not parametric because it's still not okay. You understand now? So at least at this level, we can check, can diagnose a data set from the field to check if it's normal or not. And if it's not normal, at least we can transform them using different techniques of transformation. It's important to note that square root transformation is when it's not that bad, log transformation is when it's somehow, and inverse is when it's really bad. That's how you're supposed to apply your transformation techniques. But that notwithstanding, it's always good to check. I even also check using all the available tools. And I think maybe there are further which we have not looked at them, but it's good to also investigate into all and study further. So is there any question at this level? No question. Because normally from here we are supposed to now focus on parametric and non-parametric. So from here, we are supposed to go into mean separation. After knowing their data is okay, it's important to know that analysis is based on research design. After doing all this check, it's important to know that your analysis is based on your research design. It's not every study that you use mean separations. It's not every study that you use correlation, regression, use is it ANOVA, use chi-squared. It's based on your research design. So after looking at all this, please, first of all, know your design, your study, because the next step we'll be looking at is experimental studies. In experimental studies, we'll be talking about mean separations. We are going to look at one sample. You have the independent sample t-test. You have homogeneous sample t-test. Then you have analysis of variance. We also call it the ANOVA. The concept of the one sample t-test is that you are comparing, don't bother about this, I'm just introducing the class, is that you are comparing a test value to a data set. You want to see the difference between a test value and a data set. Independent as in independent implies they are independent. So you want to see if there's any significant difference. The main concept there is that you are supposed to have just two groups. Whenever I hear of t-test, just have it at the back part of your mind that they are talking about two groups, two data set, two groups. You have what we call the paired sample t-test. Most of those who are doing passive research design, which involves the pre and the post technique, they use the paired. They have one-way ANOVA. One-way ANOVA is when you have more than two groups. You want to compare the difference among groups. You want to compare the difference among groups. And here we'll also be looking at what we call the post hoc. The post hoc now is focused within groups, even though ANOVA is among groups. For the post hoc, we shall be looking at what we call the LSD, which is a significant difference. You hear of Fisher, you have Dunet, Turkey, we'll look at that. Then we'll be looking at what we call the ANOVA table. Look at the ANOVA table. So there's also what we call factorial design, which has to do with combined effect. The effect of two factors on one outcome. But this may be those who want to study further. It's not part of your syllabus. But it's good to know it because univariate is very important for those who are doing experimental studies, who are based in experimental studies. Okay. So is there any question so far? Is there any question, anyone so far? Or give exercise for the week? Exercise for the week. Okay, take it down. Send it to those on the platform. Let me give previous exams. It's good now. And I don't need to send everything. We'll not be good at sending everything now. Just check my phone now. What's it again? Just send me a message. The phone is not there. Get to the platform and send to my number. You see my score there. Next last call. Mm-hmm. 67606. I'm not seeing it. I guess that's good. It's not covered then. Don't run, don't run. I said, don't run, don't run. Let me check the questions to answer for 5 examination. Dad, that should do one, mommy. Your phone is already. That should. That's it. Question 16. It's other question 16, 17. No. I'll forward the I'll forward the whole this thing now. I'm saying I should answer question 16, 17. Then the whole of the MCQs. So question 16, 17. Can we conclude that the following data is normally distributed? 10 marks. You put no there, you have one. In fact, attempt all the questions. Those next 2 weeks. On Saturday, send to me on WhatsApp. Attempt. 16, you still have all the marks. 16, 17. The answer is all of 16, 17, but you can attempt to others. You are done. All right. All right. So please, you stated there clearly. The composite question is question 16 and 17, please. But let's try to attempt all the questions.